Ever wonder how your phone actually works? I mean, really think about it. You tap a screen, and you're instantly talking to someone across the world, or watching a cat video from Japan. It feels like magic, right? Well, it's not magic, it's some of the most brilliant engineering on the planet. And it all started with a phone that was basically a suitcase. Let's rewind. The year is 1946. The first mobile call is made from a car, but the equipment weighs a whopping 80 pounds. Imagine lugging that around. Fast forward to the 80s, and we get the first truly portable cell phone, the Motorola Dynati AC8000X. It was nicknamed the Brick, cost about $4,000, and gave you a whole 30 minutes of talk time after a 10-hour charge. A status symbol, for sure, but not exactly convenient. These early phones worked on a simple principle: your giant phone would connect to a single, powerful tower that covered a large area, or cell. If you drove out of that cell's range, call dropped. This is where the real genius of the cellular network comes in. Instead of one giant tower, engineers decided to divide cities and regions into a bunch of smaller cells. Each cell has its own lower power tower. When you make a call while driving, your phone isn't just talking to one tower. As you move from one cell to another, your phone seamlessly hands off the signal from the old tower to the new one, without you even noticing. It's like a perfectly choreographed relay race for radio waves, happening in milliseconds. This system is what allows millions of us to be on our phones at the same time without total chaos. But just making calls is old news, right? How do we get the internet? This is where the G's come in. 1G was for those brick phones, just analog voice. 2G went digital, giving us clearer calls and our first taste of data with tiny text messages, or SMS. 3G was a game changer. It was fast enough to browse the web, send emails, and paved the way for the first iPhone and the App Store. Suddenly, our phones weren't just for talking, they were becoming portals to the internet. Then came 4G, or LTE, which is what most of us have used for the last decade. It made high-definition video streaming, video calls, and online gaming on the go totally normal. And now, we're in the era of 5G. It's not just faster, it has incredibly low latency, which is the lag time between sending a signal and receiving a response. This is huge. It's the technology that will power self-driving cars that talk to each other, allow doctors to perform remote surgery, and create truly immersive virtual reality experiences, all connected through the network. So, from an 80-pound car phone to a supercomputer in your pocket that's a gateway to the entire world. The evolution